Combination of permutations. Yeah. Right, good. So combination of permutation will start from definition, and then from definition we will be able now. So a permutation, before we define them, we have to recall the factorial. So factorials are defined at this level for natural numbers. So given a natural number n, we define factorial n as, which is given by n times n minus 1 times n minus 2 times n minus 3 all the way times 3 times 2 times 1. That's how we define factorial n. So you start multiplying n, then you multiply by n minus 1, then you multiply by n minus 2, up to the point you multiply 3, 2, and then 1. Then by convention, zero factorial is 1. Kwa pamoja?
Yes.
Good. So once we have written, you tell me so that I move to the next slide.
Yeah.
Good. So for example, when we say 3 factorial will mean 3 times 2 times 1, which is 6. 2 factorial will mean 2 times 1, which is 2. And 1 factorial is just 1. So what is the value of 4 factorial? How do we multiply? You start with 4 itself. 4 times 3 times 2 times 1, which will give us 24. And then 5 factorial will be the same as 5 times 3 So which will be 120, correct. Then 6 factorial, 6 times, why unapenda 3 sana? Which will be okay. Good. Now, for example, if I put this one in a rectangle, have you seen what I've highlighted? So that product can be written as which factorial? Yeah, so then this 6 factorial can be written as 6 times 5 factorial. Sindio? Then what if I highlight this? So the one I'm putting in the green box will be which value? 4 factorial. So then same 6 can be written as 6 times 5, 4 factorial, okay? And then if I put this in black box, so black box will be defined as 3 factorial. So I can write that one as 6. If 6 factorial is the same as 6 times 5 times 4 times 3 factorial, okay? So what you are trying to demonstrate here is that higher factorials can be expressed in terms of smaller or lower factorials. And that concept can help you to simplify some problems involving factorials. So this is 6 factorial. So 6 factorial can be written in terms of 5 factorial, 4 factorial, 3 factorial, and any other lower natural numbers than 6. So for example, if I tell you to simplify 6 factorial divided by 5 factorial, then you can have this one as 6 times 5 factorial divided by 5 factorial, and then 5 factorial and 5 factorial cancels out, and the answer becomes 6. If I give you 8 factorial divided by 5 factorial, how can I write this?
That was 8
8
times 7
mm. Mm.
itakuwa 8 times
8
7
times 7
times 6
times 6
times 5
factorial, and then divided by 5 factorial. Okay? Yeah. So what cancels out? Yeah, 5 factorial cancels out. So the answer is just 8 times 7 times 6. Can you tell me the value? What? You are sure? Are you sure? I hope you're sure. You are guessing.
No, I'm not guessing, I'm sure.
Okay, 336. Sawa sawa. Sasa ziko sawa. So write that. Hapo. Okay, so write and tell me when you are done.
Sound like
Then write these simplifications. Done. My good. So then now, once you know that, okay, let me give more other example. So can you simplify this? What is the answer? Correct, because this is going to be n times n minus 1 times n minus 2 factorial. So over n minus 2 factorial. So this and this cancels out. So we'll have n into n minus 1. So when you simplify, you get what you're saying. Okay? Yeah. So then now let's define, before we define a permutation of let's take the multiplication rule. For counting. So we'll set and then give an example to illustrate how to apply it. So let an event E occur in m different ways. Occur in there's a space here. Yeah. Let an event E occur in m different ways. So this is what you're saying, that we have let E be an event which can occur in m different ways. And associated to this event E, or once E has happened, there's another event F that can occur in n different ways. Then the total number of ways of occurrence of the two events is m by n. So the key thing here is that once one event has occurred, then there's another associated event that occurs that has occurred. So to get the total number of events which have occurred, you simply multiply the number of ways the first event has occurred, multiply by the second event. Oscar,
Yes, sir.
tena umepotea bwana. Okay, good. So that's how we this rule simply says that if an event can be done in one way, and there's another event which actually follows after one event has been done, then to get the total number of ways of doing the same event, you simply get the product. Okay? So and this can be extended to more than 2 events. So there can be 3, 4, 5, or up to n events, up to k events. So for example, the roads connecting 4 towns, A, B, C, and D, are as given below. So we have town A, we have town B, we have town C, we have town D. So I have this route, this route, this route. So to move from town A to town B, there are 3 different ways you can move from A to B. Then there's another route, there's another road, there's another road, there's another road. So to move from town B to town C, there are 4 different routes one can take. And then we have this route, we have this route, we have this route, we have this route, we have this route. So 1, 2, 3, 4, 5. Say R1, R2, R3, S1, S2, S3, S4, T1, T2, T3. Please put one of the gadgets on zero mode, zero volume. So the question is, find the total number of ways of moving from town A to town D through B and C. So find the number of ways moving from town A to B, passing through town B and C. So that's the question. Once you have written it, let me. Hey bwana, sasa hivi tutaki mchezo. Tutaki mchezo. Eh? Sawa. So this is what's happening. So how many different ways can we move? There are 3 different ways you can move because there are 3 roads, okay? And then how many different ways can you move from town A to town C? 4 different ways, because there are 4 roads. And how many ways can you move from town A to town B? 5 different ways, because there are 5 roads, okay? So then now we can make a box, and then we partition it in 3 parts, where the first box is actually number of ways of moving from the first town to the second town, and there are 3 different ways. Then the second box is how to move from town A to town C, which is 4 different ways. And then the other box is how to move from C to D. How many? 5 ways. So therefore, the total number of ways by product will be simply given by 3 times 4 times 5. Total that 60. So 60 different ways of moving from town A to town B through town B and town C. Okay. Yeah. Problem 2. In a lecture room, are labeled with a letter of the English alphabet or simply of the alphabet. And a positive integer not exceeding 100. What is the largest number of chairs that can be labeled differently? Okay. Yeah, I'll copy the question. So once you have copied the question, let me know. Good. So here, how many tasks are here? How many boxes are we going to have? What is the task? Or what are the events that are supposed to happen here? Labeling. So labeling chairs with the alphabets and then followed by not exceeding 100, okay? So how many, so there are two, so we know that there are only two tasks. So we will label the letter of alphabet, and then once we have done with the alphabet, then you label with the first integer not exceeding 100. So then solution. So you draw a box and partition it to how many parts? Two parts, because the first event is to label with a letter, then followed by labeling the positive integer not exceeding 100. So what is the number in the first box? How many different ways can we label with an alphabet? 26, because we have 26 letters. Okay? Yeah, so you write here 26. Then second box, we will need to label with a positive integer not exceeding 100. So how many are they? 100, okay? Na tungesema a positive integer less than 100, ingekuwa 99, correct. So note that when you say positive, tunaanzia 1, 2, 3. To say not exceeding 100 inamaanisha we still count 100, but tuwezi pita 100, okay? Yeah. So here we have it. So then by product rule or multiplication rule for counting, we have 26 times 100, which is 2600 different ways of labeling the chairs. So if we have 2600 different ways of labeling chairs, so how many chairs can we label maximum? The same number, okay? Yeah. So therefore, we have 2600 chairs that can be labeled differently. So that's what I'll have for that problem. So once you're done that information, let me know and the next. Once you're done, you let me know, okay? Good. Then the other question is, in how many different ways can a quiz be answered under each of the following? Conditions. So the first one, the quiz consists of three multiple choice questions with four choices for each. And then the second condition, the quiz consists of three multiple choice questions with 4 choices each, and 5 true false questions. Good. So we just have to know, in the first case, the quiz consists of 3 multiple choice questions with 4 choices for each. So how many boxes do we need to interpret this? One box will be for? Mm. Okay, so maswali kwanza ndio niambie. Read the question first, then what you're supposed to do. So I want to know in how many ways can a quiz be answered under each of the following conditions. Quiz consists of 3 multiple choice questions with 4 choices for each. And then the other case, the quiz consists of 3 multiple choice questions with 4 choices in each and 5 true false questions. So how many boxes do we need? Your friends should help you to interpret. You are not the only one. So both of you should participate, not just one person. You should not keep quiet. Ya kuja hapa kulala, kama kulala ende hostel bwana. Hajakuja hapa kulala, kwa na mdomo aongee, wacha asi nyamaze bwana. We'll kick him out of this class. 2. So one box will be having. And then the other box. Okay, good. So how many multiple choices do we have in the question? Tuambie part A. Kuna ngapi? And then kila swali iko na majibu ngapi? Kila swali iko na majibu ngapi? Iko na 4 options, ndio? Ni kama zile maswali za primary. Unakumbuka what used to answer in primary school? A question has for A, B, C, and then you pick one. So now with that understanding, how many boxes do we need? Hey. 7 tena inatoka wapi? Sasa inakuwaje Oscar, inakuwaje tu bwana? Na tumeambiwa hii ni this quiz iko na maswali 3 na kila swali iko na 4 choices. Sasa tutakuwaje na box 2 na 7? Si kila swali inakuwa na majibu yake. Tumeambiwa majibu ngapi? Wewe bwana. Every question has how many choices for the answers? Huh? So then sasa nauliza, in the structure of our answer yafaa tukuwe na boxes ngapi? Hmm? The first thing to know how many boxes we need to have. You want to kuuliza in each box, how many values should I have? What number should I put in each box? If I speak, you didn't come here to sleep. Yes. You are saying? Yes, I'm writing in black. If you are saying black, then it means that you are very normal because I'm writing in black. So Ephraim, tell me, how many boxes will I have in this? Hmm. 3 boxes. Sasa hiyo box, kila box ina represent nini? Question moja moja. So tuambia ziko na 3 questions, ndio? Yeah, so we'll have 3 boxes, correct? So we draw this. So now the interpretation of what we are drawing here is that kila box ina represent swali moja moja because we have been told that there are 3 multiple choice questions, ndio? Yeah, ziko maswali 3. Na sasa how many ways can we answer the first question? There are 4 because there are 4 questions, ndio? So naandika hapa ndani naandika 4. And then how many ways can we answer the second question? Still 4 because we still have 4 choices, okay? How many ways can we answer the third question? Still 4. Yeah. Yeah, so then you say by product 4, we have 4 times 4 times 4 times 4, which will be 64. So that will be the number of ways of answering that because the class only got 4 choices. Now, there are only 3 questions, okay? Yeah, so each box in this context will be representing that question. Good. So note that what we are discussing actually, combination and permutation is actually under counting. So we are solving counting problems. So later on now we'll define what permutations and combinations are. These are counting problems, okay? Then those are part B. The quiz consists of 3 multiple choice questions with 4 choices each and 5 true-false questions. This is Ephraim question, is not Oscar. Oscar, you have answered your part A. Ephraim, now tell us, how many boxes do we need in this case? Ephraim, how many boxes? 4. So in your answer, each box in represent any? Now, umesema how many boxes do we need? Oscar, do you agree with that? Oscar, do you agree with that answer? What do you think is the correct answer? Hmm. Hmm. So jibu ni 3. Bona. Hmm. Hmm. Mm. 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 8. So what is the interpretation? Why 8? Mm. Correct. So we have 8 boxes. So we draw this. So we have 1. So remember, in this context, killer box now represent the question, okay? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that the first 3 boxes ni za zile zenye ziko na majibu yao 4 each. The last 5 are those with true false answers. So how many ways can I fill the first box? 4, because that question has 4 answers. And how many ways can I fill the second box? Oscar, wewe 5 unatoa wapi bwana? Angalia, the first 3 boxes na hii part ya kwanza 3 multiple choice questions. Sawa? Haya. Sasa tunajaza namba gani hapo? 4, correct. And then how many ways can we fill the next box? 4. How many ways can we fill the next box? 2, because true false is gonna 2 answers, okay? And then how many ways can we fill the next box? 2. How many ways can we fill the next box? 2 again. How many ways can we fill the next box? 2 again. And how many ways can we fill the last box? Correct. So then I say by product rule, we have 4 times 4 times 4 times 2 times 2 times 2 times 2 times 2. So niambie hiyo ni itakuwa nini? Hey bwana, wewe una perform miracle. Wewe are a miracle performer. Natipatia nini? Pana bwana, acha uongo. Ebu check your answer. 2048, correct. Should be 2048. Good. Sawa. Sasa hii hapa hii msipopata kuna sapa leo. So this is the next one. A new company. This one I'm not doing it. I want you to do it. You can discuss and tell me what you think. A new company with just 2 employees. Sam and Peter rents a floor of a building with 12 offices. How many ways? Are there to assign different offices to these 2 the father. Well, to these 2 employees. How many different how many different ways can we assign offices to these 2 employees? Please don't take away your common sense. Yeah. So write the question and then work out and tell me the answer. I give you 1 or 2 minutes. For 1 minute remaining. The time of solving the problem has elapsed. What answer do you have?
Does not elapse.
1? Mm. 2, correct, because kuna watu wawili, si ndio? Good. Haya, so we have 2 box and then followed by? Yes. Okay, so let's say we start with sum. How many ways can we assign the first person? Well, because there are 2 available offices. And then once we have assigned one office to say sum, how many ways can we assign another office to people? 11, kwa sababu huyu mwingine atakuwa amechukua office moja, si ndio? So atakuwa amereduce from now 12 to 11. 12 to 11. Nyinyi mko sawa. Yeah, ningekuwa karibu ningeanulia chai. So this will be 12 times 11, which is 132. Okay? M-Pesa yangu iko na shida. Ningekuwa karibu ningeanulia chai. So let me just give another formal definition of cases. So formally, this is how we can set the product. So given or suppose that a procedure can be done in a sequence of two tasks if there are n1 ways of doing the first task, And for each of these ways, of doing the first task, there are n2 ways to do the second task. Then there are n1 times n2 ways of doing the procedure. Or there are n1 times n2 ways to do the procedure. Right, that's so there's a dependence on once the first task has been once the first task has been done, then you when the first task has been done, then there's another way you bring the second task, depending on the first one. Okay.
Yes.
Yeah. So once you're done, you let me know so that I can give the generalization to more than 2 tasks.
So we're done.
Good. So we can also give an extension for the same when we have more than 2 tasks. So extension of the product rule. So suppose that a procedure is carried out by performing the tasks T1, T2, T3, all the way up to Tm in sequence. So please respect this word sequence. Sequence means that now that the first task, the second task depends on the first, third depends on second, fourth depends on third, etc. So yeah. So if each task Ti for I from 1, 2, 3, all the way up to M is done in Ni or say in Mi ways. Okay, let's use just a different letter N. If each task is done in Ni ways, regardless of how the previous task were done then there are n1 times n2 times n3 all the way times nm ways of doing the procedure. Sawa?
Yes.
Yeah, so just the same way we have said, when you are answering the multiple choice problems, so we saw that there are more than 2 tasks to perform. So you draw 3 boxes or more than 2. The other question is draw 8 boxes. And once you know what to fill in each of the boxes, then you just multiply the values. But the condition is that the second task depends on the first, and third depends on second, Ivo. So, yeah. So there is what we call sum rule also. The sum rule. So I'll give the definition of sum rule and then also do some example, okay? Yeah. It's still the same way. It's still the same. It's still the same thing. Yeah, yeah. What really is that now? The way of doing the first task, or the way first task, the number of ways the first event can happen. Then the second event or the second task depend on the first one. So you can give the definition in terms of tasks, or you can give the definition in terms of events. Okay. Yeah. So the sum rule will state and then give an example. So statement. So give statement first by using 2 tasks, and then we generalize to n tasks. So suppose a task can be done in one of n1 ways, or in one of n2 ways, where none of the set of n1 ways is the same as any of the n2 ways, then there are n1 plus n2 ways to do the task. So I want you to master the difference. We are saying that
Yes.
If a task can be done either in any one of n1 ways or in any one of n2 ways, where none of the sets of n1 ways is the same as any of the n2 ways, but there's no relationship between n1 and n2, then the total number of ways of doing the task is simply the sum of the 2 ways. So the key thing is that one set or one way of doing a number of ways of doing the first task is different from number of ways of doing the second task. Then to find the total number of tasks, then you simply add the 2 ways of doing the 2 tasks. Unlike in the previous rule, where we say that when the task is done in N1 ways, then N2 ways of doing the second task depends on the first task having been done. Are you getting the difference?
Yes.
Yeah, that the upper sum rule, number of ways of doing the first task does not depend or relate to the other way of doing the second task. But in the product rule, the second task depends on first task having been done. Okay?
Yes.
Yeah, so let me give an example to demonstrate this. So suppose that either a member of the mathematics faculty or a student who is a mathematics major is chosen as a representative to a university committee how many different ways? Are there for this representative if there are but 7 members of the mathematics faculty and 83 math majors and no one is both a faculty member or a student and a student. Do you know that it's possible for someone to be a student and a faculty at the same time? Yeah, correct. So then suppose that there is either a member, suppose either a member of the mathematics faculty or the student who is a mathematics major is chosen as a representative to a university committee. How many different ways are there for this representative if there are 37 members of the mathematics faculty and 83 mathematics majors? This number is 83. And no one is both a faculty member and a student. So you are either a faculty or you are a faculty member or you are a student, not both of having both places. So how many ways are there to choose a faculty member? How many ways can we choose a faculty member to this committee?
37.
37, because there are 37 of them, okay?
Yeah.
And how many ways are there to choose a student who is a mathematics major to this committee? 83, correct. So therefore, and remember we've been told that there is no one who is both a faculty member and a student. So then there are 37 ways of choosing. There are 37 ways of choosing a member of mathematics faculty, and there are 83 ways to choose a student who is a mathematics major. And then choosing a member of mathematics faculty is not the same as choosing a student who is a mathematics major. Why is that the reason? choosing a member of mathematics faculty is never the same as choosing a student who is a mathematics major. Why is that so? Why do you say that? Correct. Because we have been clearly told that there's no one who is both a student and a faculty member, okay? Yeah. So therefore now, this one now agrees with the definition of the thumb rule. Because thumb rule says that if a task can be done in any one way or in any two ways, where there's no relationship between n one ways and n two ways, then the total is simply n one ways plus n two ways, okay? So therefore, we have by thumb rule, we have 37 plus 83, which is how many ways in total? 120. We have 120 ways of making this choice. The key thing here is that there's no relationship between someone being chosen as a faculty member or someone being chosen as a student, because there's no one who is both a faculty member and a student at the same time. Okay? Yeah. Example 2, for you to actually get things out of, or to clearly see the difference between how we apply the sample and product rule. So a student, example 2, a student can choose a computer project from one of three lists, A, B, and C. The three lists contain 23, 15, and 19 possible projects, respectively. No project is on more than one list. How many possible projects are there to choose from? How many possible projects are there to choose from? So once you have written the question, you let me know so that we can discuss it. Good. Are you done?
Almost.
Okay.
So I'm done.
Good. Now, how can a student choose a project in this class? Yes, the student can choose a student can choose a project from either list A or list B or list C. Okay. Yeah. So let's write that. So solution: a student can choose a project from list A, B, or C. Now, how are these projects structured? Mm, mm. So list A has how many projects? And then list B and list C. Then what other information have we been taught? Correct. So then now, since no project is on more than one list, then by some rule, we have, so just get a sum, 23 plus 15 plus 19. So what would be the total? 57 ways to choose a project. So that would be the answer. So immediately now, to know the separation between application of product rule and sum rule is that for sum rule, you have to be told that the way of the first task, second task, third task, it is still happening or occurring is independent or does not depend on each other. And there's nothing common between the tasks or the number of ways of the events occurring. So if that information is very clear, then it tells us that actually we have separation. So we'll be doing the addition of the total number of ways. We'll be doing the addition of the number of ways given to find the total. But now for product rule, there is a procedure which is in sequence form such that the second step is affected by the first step, and then the third step is affected by the second step in that order. So
Yes.
yeah, and no one, remember, when you are solving a counting problem, no one will tell you that this is the point to apply sum rule or this is a point to apply the product rule. You have to read the problem and understand which one you have to pick. Okay. Yeah. So there's also different rule. Different rule is the same thing we do on set theory. The inclusion exclusion principle is also called the different rule. Yeah, so hiyo ndio tunafanyia kwa set that they say cardinality of A union B is cardinality of A plus cardinality of B minus cardinality of A union A intersect B is what we also call the difference rule. Okay? It's still yes, yeah, that's still under counting techniques. Only that we actually mostly discuss it when we are doing sets because it's mostly related to. But that formula of inclusion exclusion principle is also called this difference rule of counting. Okay? Yeah. So now this next question will involve application of both product and sample. So let's write it and then discuss, see how the relation should be. So each is going to be testing on both sum and product rule. Yeah, this next example. Yes. But yes, I can share the end of this. Okay. So each user on a computer system has a password which is 6 to 8 characters long. Where each character is an uppercase letter or a digit. Each password must contain at least one digit how many possible passwords are there. So once you have written the question, let me know. Okay.
I'm done.
Good. Let's agree. When we say each password is 6 to 8 characters long, so inamaanisha password inakaje in this case? What are the options? Inaweza kuwa na 6, 7 or 8, sindio? Yeah, so let's say solution. Let P be the total number of passwords and then let's have P sub 6, P sub 7, and P sub 8 be total, not really total, be password is if you use word total also confuse people. So let's just let this P6, P7, and P8 be passwords whose length is 6, 7, and 8 characters. Respectively. Oh. So P6 inamaanisha all those possible passwords with 6 characters, and P7 means all those passwords with 7 characters, and then P8 means all those passwords with 8 characters. So, yes. A password which has 6 characters and a password which has 7 characters, is there any relationship between the two? A password with 6 characters and a password with 7 characters. Is there something common to them? There's nothing common, okay? And then similarly, a password with 7 characters long and a password with 8 characters long, they have nothing also in relation, okay? So then, which means, okay, by me saying they have nothing in common inamaanisha, kama mtu ako na password yenye iko na 6 characters, akitumia 7 characters, it will not work. Akiweka 7 characters, then it will not actually function because it may an excess, okay? And then if the password is 7 characters long, then also you cannot use 6 characters or 7 characters and it work. It will not work because it will be excess or less, okay? So what is the relationship between P6, P7, and P8? How are they related? How do you get the total number of passwords? You add them. We apply some rule because hakuna the password with 6 characters has nothing to do with password with 7 characters and similarly has nothing to do with 8 characters. Okay? So that is why we are going to say that we are going to add them. We are using some rule because there is no relationship between password of 6, password of 7, and password of 8 in terms of the structure of the length of the passwords. Okay? Yeah, so therefore we say by some rule, P will be P6 plus P7 plus P8. Okay? So P6 inamaanisha iko na how many characters to be filled? 6. So tunaweza chora, we can draw a rough sketch of a table with 6 spaces, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. Okay? What is the condition for each password in this question? What is the condition for each password in this question? Correct. That is the key thing. That's tunatumia digits na tunatumia letters, but the condition is that it must contain at least 1 digit. So, kitu ya kwanza tufanye tujiulize, how many digits do we have by the way? Tunakuanga na digits ngapi? There are 10 digits, 0, 1, 2, 3, 4, 5, 6, up to 9. So there are 10 of them, okay? And how many letters do we have?
26.
26 letters, okay?
Yeah.
So these are the characters. So what is the total number of characters you have to me? Because we will be having digits and letters at the same time. What is the total number of available characters that we'll be using to fill these spaces?
36.
36, just the sum of digits and letters, okay? But let's see, to know what to fill in this spaces. I want you to tell me whether it is a possible password or it's not a possible password. These numbers I'm filling. If I put here 1, 2, 3, 4, 5, 6, will it be in agreement with the condition in the question?
Yes.
Because these are digits, okay? Then if you want A, B, C, D, E, F. Why is the reason? Okay, so let's okay. What before you give me the answer, before you tell me the answer, let me wrap this. Let me have this because I can guess what you wanted to tell me. Let me write this before you answer. If I have A, B, C, D, E, F, is it a possible password or it will not work according to the question restriction? Will it work or it not work? It will work. You are sure? Huh? Yeah, sasa hapa tulikuwa na A, B, C. Sasa hiyo condition inamaanisha this A, B, C, D, E, F is not a possible password for this case, okay? Because yafaa tuone at least one digit mahali kwa that password. So this will not work, okay? So things of this form will actually not work. But things which have at least one digit or one digit or all digits will always work. So the question will be, how do we know passwords which will be having at least one digit and passwords which will not be having any digit? It is very easy to know those which will not have any digit because it's all the alphabets, okay? Yeah, so which means then, for us to know the correct passwords which will be having the restriction given in the question, we need to fill these boxes in such a way that we eliminate all the worst passwords which do not conform to the question restriction. That I mean, we remove all the passwords which actually will be having all their characters to be alphabets. So then, to do that, I will get all those passwords by using all the characters I have 36, regardless of whether it is a digit or it is a letter. And then I subtract those passwords, which are, I'm sure that all their spaces, all their 6 spaces are actually filled by letters. So then the P6, I will remove, I draw here another box of 6 spaces. And that box that I'll be removing from this first box is a box which will have all the characters in the 6 places being alphabets. So 1, 2, 3, 4, 5, 6. So these are the worst in quotes. So the worst means they are all the 6 spaces are filled by letters. So how many ways can I fill this box with an alphabet? How many ways are there for me to choose from? 26. And then how many ways can I also fill this box with a letter? How many ways? Can I fill this box with a letter? A letter can be filled. We didn't have that restriction that repeating is a problem. But wakituambia, angalia, so this how we interpret it. If they tell you that, I hope you know that even in your own personal documents or things which involve passwords, when you're working on your computer, it is still possible for someone to have an AA and it still work. Maybe AA, small a, 1, 2, and 3. This can be a password for someone, okay? Yeah, so repetition is not a problem. We don't have that restriction, even in this question. So how many ways? Still 26. This other one? 26, this one? 26, this one? 26, this other one? 26, correct. Then here, kwanza, we put all the characters regardless of whether they'll give us the best or the worst passwords. So how many total we have? 36. So this box can be filled by the 10 digits or it can be filled by the 26 alphabet. So total 36. These are the box. 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 36. Correct. So then now, by product rule, the first one will be 36. How many times? 6. So 36 power 6. So P6 will be given by 36 power 6 minus this other one will be 26 power 60. So can you work out and tell me the answer? Don't fear the number. Okay, so just read 1, 8, 6. Mm. 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 Correct. So that is the P6, okay? And then P7 has the same interpretation. Passwords having character 7, utachukua zile total, then you subtract the one that actually cannot actually be possibilities, okay? Yeah, so P7, a box now with 7 spaces. 1, 2, 3, 4, 5, 6, 7, minus those words which can actually never work, where all the spaces will be having letters. So 1, 2, 3, 4, 5, 6, 7. And actually it has the 6 followed by 6, 6, 6, 6, 6, 6. Hai box ingine? 26, 26, 26, 26, 26, 26, okay? Yeah. So hapa kutakuwa na 36 power minus, correct. So then, minus 26 power 7. Don't fear the number. 7.033 23 53 92 times power 10, correct. So similarly, P8 will be given by 36 power 8 minus, correct. So minus 26 power 8. So let's work out that and see. Two point 2.61 22 82 84 times 10 power 12. Okay. Good. Now, the answer to our question was P. So P is P6 plus P7 plus P8. Sasa ongeza zote uniambie umepata ngapi? Jibu inakupatia nini?
Just a minute.
Sawa, malizia. Inakupatia nini? Angalia je nimeandika, is it agreeing with what you have? Check what I've written and see whether it's agreeing with us. Correct. So that will be the answer to that. Okay? Yeah, so that's why we apply both product and sample. So I'll share this one. So I'll give you time to write. So allow me to go to the next. Okay. So then now we are mature now to define a permutation and combination. So you have seen that the product tool and sum rule, you have to be very careful on how to apply the two. So yeah. So let me define permutation and combination. After that one, then we do an example and also see how you can. So permutation. So an ordered arrangement. Yes, we should be stopping in 10 minutes time. Okay? Are we together? Yeah, in 10 minutes time we'll be stopping. So an ordered arrangement of R objects. I want you to write this without repetition. Selected from n distinct objects is called a permutation. Of n objects taken R at a time. Okay? Yeah, then we usually denote it by this. We write P into n comma R, or we write P n R, or we write P n here, then we put R here. And then the formula is given by n factorial divided by n minus R factorial. So write that once you have written, let me know.
Okay.
Good. So then now I define combination and then I give one example each and so combination. So combination means an arrangement of R objects without repetition and without regard to order selected from n distinct objects So that's what we have as a combination, an arrangement of R objects without repetition and without regard to order, selected from n distinct objects. So also give notation and formula. So C of n comma R, or we write this, or we write it's like a matrix. Then C nr is n factorial divided by R factorial into n minus R factorial. Huh? Yeah, so this is what you have. So I want you to check the definition of permutation and definition of combination and tell me what's the difference. Yeah, both of you discuss and tell me what is the key difference between combination and permutation. All of them are arrangements of R objects from N objects, but what is the main difference between the two? From the statement of the definition, what is the key difference? Mm. Mm. A combination? Mm. check, 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 check. Check what you have written. You have correct explanation, but you are mixing up yourself. Actually, what the statement you are giving is the correct answer, only that you are now reversing what you should explain word for word. Which of the two, permutation and combination, order matters? Permutation order matters, and combination? Yeah, so that's the main difference. So in Kamavile, when we are doing the sample and product rule for counting. So counting, when you want for you to know that you need to apply product rule, unajua that tasks are happening in a sequence. ya pili inafanyika kama ya kwanza imefanyika, then ya tatu inafanyika kama ya pili imefanyika, sawa. Na vile tulienda kwa sum rule tukasema the two tasks, the number of ways of them happening should actually, they have no relationship, okay? So the same here for combination and permutation. To know that you need to apply permutation formula, yafaa ukuwa umesoma swali, and then from the question itself, you see that this question respects order. That's when you know that you need to use permutation. So, and when you read a problem and you see that order does not matter in the arrangement, then you know that you are going to use combination formula. So, yeah, so I want to give two examples. One of them will be testing on combination, another will be testing on permutation. But I will want you to tell me which one is testing on what. If that one will be done, then I'll stop. If you will be able to tell me the separation, after reading the problem that this is testing on competition, I'll be sure that now you have understood what you have done and I'll stop. If not, we'll go up to 10. Yeah, so for us stopping depends on your response. So take it seriously, okay? So example, so I'll give two and then I want us to read and interpret which one requires permutation, which one requires combination. So the first one, says that in how many ways, if a club has 20 members, how many different member committees are possible? So if a club has 20 members, how many different 4-member committees are possible? And then the other problem, number 2, the last one. A club has 20 members. The officers of the president, vice president, secretary, and treasurer. And no member may serve in more than one office. So how many different slates of candidates are possible? So those are the two problems. So write them, and I want you to tell me which question tests on combination and why, and which question tests on permutation and why. If you're able to tell me that one, then I'll be the one now to solve the question themselves. But I want you to to help me get the classification. Which one is testing on combination and why? Which one is testing on permutation and why? Yes. What, question 1, test on permutation or combination. Why? Correct. So here, because we have this club has only 20 members, and we need committees of four people. So it does not matter how we are going to arrange these 4 people. It's just the key thing is that it's a grouping of just 4 people, okay? Yeah. So order does not matter here. So therefore, this is a combination problem, correct? And then the second one? Yes. Why?
That matters because starting in respect to start.
And treasure. Correct. So here, this is a permutation problem because there's some element of respect to order, okay? Good. So therefore now, question 1, solution. It's a combination problem. Order does not matter. So remember, we just need to know the value of n and the value of r. So what is the value of n? N means total. N is 20, so n is 20. R means how many are we supposed to select at a time? 4. We need 4 members in each committee, okay? Yeah, na tunajua n combination r is given by n factorial over r factorial into n minus r factorial. So this will be 20 factorial divided by 4 factorial into 20 minus 4. I'll share this one. So just concentrate on understanding, okay? Yeah, over they are 20 minus 4 factorial. So what is 20 minus 4? 20 minus 4 is 16. So we'll have 20 factorial divided by 4 factorial times 16 factorial, okay? So we reduce this 20 factorial up to 16 factorial to cancel out, okay? So tutakuwa na 20 times 19 times 18 times 17. Then we stop at 16 factorial divided by 4 factorial is the same as 4 times 3 times 2 times 1, then times 16 factorial. So 16 factorial and 16 factorial cancels out. 4, 1, point to 20, 5. 3, 1, 3 into 18, 6. 2, 1, 26, 3. So tutakuwa na 19 times 3 times 17. Abuni work out and tell me. Oh, times 5. Watu wanaona mbali bwana. Mlisema tutaenda mbali, hapa ni wapi? Correct. 48, 45. So, yeah, so that will be the answer to that one. And then question 2, this is a permutation problem because there's an element of respect to order, okay? Permutation, since order matters. So once you know that it's a permutation problem, order matters, they all just also need to identify n and identify r, and then correct from there. What is n? N remains to be 20. R? R is for because there are 4 states to be filled. Yeah, then we know that permutation of n r is n factorial divided by n minus r factorial. So we just replace accordingly. We have 20 factorial divided by 20 minus 4 factorial. Then 20 minus 20. So I'll have 20 factorial divided by 16 factorial. So it will be 20 times 19 times 18 times 17 times 16 factorial divided by 16 factorial, okay? Yeah. So 16 factorial cancels out, tunabaki na 20 by 19 18 by 17. Sasa bomoa tuone tutapata ngapi? 116,280. So that will be the answer, okay? Then now I want you now, before we meet next, I want you to, I'll send you, but I'll send you the handout, but write short notes plus examples on, so one, the only two tasks, permutation with repetition. And then number two, combination with repetition. So,
Yes.
yeah, so you write the formula for combination with repetition, permutation with repetition. Now you write one. So,
Yeah.
So these are the main take home. We have done four main things. First, it was to discuss about the product rule or the multiplication rule for counting. And then we say that for you to apply product rule, you need, it is different ways of doing a procedure. So the one way of doing the same task, and one ways of doing a task. And then once first task is done, the second task is done in n2 different ways. Then to get the answer for the total number of ways of doing the procedure, you multiply n1 by n2, okay? Please listen to my closing remarks. You will have time to discuss. This is very key. Product rule, you have to do a procedure or which involves more different tasks. So if there's n ways of doing the first task, and then there are n2 ways of doing the second task after the first task has been performed, then the total number of doing the procedure is n1 times n2. And the same can be extended to more than two tasks, okay? Then for sum rule, you want to do a procedure such that there are n1 ways of doing the first task, or there are n2 ways of doing the second task, whereby n1 and n2 has no relationship, okay? Then the total number of ways of doing the procedure is n1 plus n2. And you can as well generalize to n1, n2, n3, etc. Okay? Then the main difference to know when to apply the sum rule and the product rule is that for product rule, the different ways of doing the tasks are interrelated, such that the second task depends on first task having been done. The third task will happen when the second task has been done. There's some sequence, okay? And then the sum rule, to know that that's the problem is testing on sum rule. You actually, the key thing is that there is no relationship in the different ways of doing the tasks. Okay? And then we come to combination and permutation. All the two terms is on arrangement of n objects taken R at a time. Okay? But the key difference is that for permutation, the order is respected, while combination order does not matter. And then we have given the formulas for combination, and we have given the formulas for permutation. So this is the formula for combination. We have given it here, and this is the formula for permutation. We have given it here. So once you have actually read the problem and known that order matter or order does not matter, then it's the one that will drive you to know which one to apply. So yeah, so then go and write on combination is repetition and permutation is repetition. Once you have understood the basic, then you'll be able to follow through. So yeah, so let's stop there. Okay. Tomorrow we can meet